Hello Internet! Today we're going to be looking at Spock unit testing in Java or Groovy or any other JDK, JVM driven environment. So Spock is primarily a Groovy based testing framework, so it's all written in Groovy. It does a lot of groovy things, and because of that it can do some really cool things. It's one of probably my favorite testing frameworks just because it's very easy to understand what is actually happening, and because of that it makes it really easy to not just define like tests, like programmatic tests like this does this, but also to define business rules in a way where your business partners or whoever you're doing whatever you're doing for can look at it without really any technical experience and actually kind of know what's going on. And I think that is what makes it really powerful. So we're going to make some really basic tests in this. It's going to kind of introduce some of the core features of what Spock can do. We're not going to get super in depth. We're not going to write some really complicated tests. I don't really think that would be that helpful. We're just going to look at what you can do with it, and then you guys can figure that out for yourself. So like I said, it's Groovy based, so you need to include Groovy, which I have done here. We have Groovy included 2.4.12, so 2.4.12 is the version for Groovy. And then we're using Spock 1.1. And so then we also have the Groovy plugin. If you don't have that, IntelliJ has no idea what you're talking about. So then we go here, create a, I have a separate module for testing, and then just create a Groovy folder. We could match the package names to what we have in our main test folder. This is just our getting started with Spring example app. We don't need to do that though. That isn't required. So we can actually just go here and create a new Groovy class. We'll call it, say, hello Spock. And so this is what you get when you create a default Spock test or default Groovy test. This is going to be just your default thing. Since I don't really do a lot of Java stuff, I still have the default IntelliJ thing. We can get rid of that. It's not needed. So we have these two lines. What we need to do before we do anything else is extend our specification. And so this will import the Spock Lang specification class. And this is what actually defines a test. If you don't implement this, nothing is going to get run and nothing is going to happen. So that part's important. You can have things in your test folder. If they don't extend a specification, they aren't going to run. So that's the first bit. We have our class, and now we can define a method. So this is the first cool thing. In Groovy, I don't know if this is a good idea, but you can define methods without or with spaces in them. So if you do define a method and then just use quotes and say are equal values equal to one another. Yeah, sure, we'll do that. Equal to one another. I hadn't really decided what I was going to test until just there. That's an interesting test. And so this is going to be a test of are two things equal to one another. And so what we can do is say we're going to expect two values to be equal. And so this isn't a comment, or this isn't a code line. This isn't anything that's going to execute. You won't see this anywhere except in code. It's a comment about what you're supposed to do. And so you can kind of use this as a way to build what it is. And so the idea, there's a number of these jumps, I guess, labels. You can use a number of these labels to kind of build what you're testing. So something might look like given a notebook. Sure, we'll do a notebook. Given a notebook and a, what else do we have here? Guitar pick? Sure. So given a notebook and a guitar pick, when the notebook is opened, then the guitar pick, I don't really know where I'm going with this, but this is sort of the idea here. Then the guitar pick can be put on the notebook. Yes. And so think of this as sort of the outline for your test. You can do this before writing any code, and it's very obvious what you're trying to get across. And so each of these are actually valid Spock things. This is a valid test if I actually filled this out. We're not going to use this because it doesn't exactly make any sense. But that's sort of the idea. You can write that, or more likely, you're going to have somebody that has already written something that looks very much like that, and you can just put that in a test and implement it, and you're good. You know it's fulfilling that business rule because that's what you were told to do. And so that makes it really, really nice. I haven't used another testing framework that really does that. And so that is something that I really like. Expect is an alternative. It's sort of a combination of a when and a then. So then is going to be your test, your asserts. And then when is going to be when something happens. So there's a setup, like that's what the given was. And then there's going to be a when, and then there's going to be a then. So when something happens, then this should happen. That's the basic of it. Expect is just easier. So effectively we could say expect 2 to be equal to 2. Right? That makes sense. So if I do go and run this, we should be able to see, it'll take a bit. We'll see it runs in the hello, and you'll see this is going to be super small because I can't figure out how to scale IntelliJ. I tried and I failed. But what you get is you get a list out of the class names. So we see hello Spock as the class here. And then we actually see this string, which makes it really nice because it's all nice and delimited because we put spaces in it. So it's just a sentence. And so it says are equal to one another. And that's true. So we don't get anything. It's just the test passed. Now, if we do say 2 is equal to 5, like this, and rerun these, we should see a failure. And Spock is going to actually show us what failed. So it will show us the equalities that failed. And then it will also give us the expected and the actual result. And so the cool thing is we can just plug in functions like this, and we don't have to do, like normally you'd write some sort of assert, 2 is equal to 2. You can do that still, but you don't need to. So this is just sort of an implied version of that. And there's a lot of other cool things you can do with this. You can test, for example, to make sure that a function was called. So let's do that. So let's actually, we'll get to that. So let's say we're doing expect 2 values to be equal to one another. So what we want to do is we actually want to test multiple different values. So it's possible for, if I implement this equality, to just say if the value is 2, then just return true. And for any other value, so if I tried like say 3, then return false. And obviously we don't want that. And so if you want to test multiple things, you could use a where clause. And so this is very similar to data-driven tests and other things, but Spock lets you implement it as a table. So we're going to have, say, value 1. These are not the best names, and value 2. And so we'll do that, and we'll actually even say expected equality. And so this isn't required, the double double lines aren't required in Spock, but it's sort of a way of separating the inputs of our two values and the outputs of our expected equality. So we're given a value 1 and a value 2. We're expecting them to be equal. And so those are the labels. Those are what the things are called. So we have 3 new variables we just introduced. We have value 1, value 2, and the expected value. Those can be used up here. So now I can take that value 1, you can see it saying it's an object, and value 2, and we're going to compare them and say that should be equal to the expected equality. So this gets a little bit confusing, but so what we're doing, we're comparing the two and effectively calculating an equality and then saying, is that what we expect? And so our test could be, we want 2, let's line these up here, to be equal to 2. So 2 and 2 should be true. 2 and 3 should be false. And so that gives us both a true and a false case. And then just for fun, let's add in a failing case so we can kind of see that happen too. And so 1 and 4 should be false, but we're going to say we're expecting it to be true. So that case is going to fail. So if I rerun these, we're going to get a failure. And so we get 1 and 4 are false. And the cool thing is, hopefully you can see that, but it doesn't just list the values, the expected and the resulting values. It lists every value in this statement. So there's actually 5 values here. So it's listing 1 for value 1, 4 for value 2. The comparison between them is actually false. So we know that this statement evaluated to false. We don't have to write an extra test for that. We just get that. We also know the expected equality is true, and then the equality evaluated to false. And so that is sort of how that works. It deconstructs it for you, which is more than you might normally see in some testing frameworks. So that's cool, but we only got 1 test here, which is weird because we have 3. And so it's hard to tell here. You would get multiple failures if we made multiple of these fail. We'd get multiple failures, but it's hard to look at this and be like, oh yeah, I have 1 test failing when there's 3 tests there. You don't even know that 2 of them passed. So how do you make that work? Spock has thought of that. There is an unroll. And so if I unroll this test, when you have a where block, it unrolls each of these rows into its own separate test. So if I run this again, we'll see 3 different tests, and they'll be numbered 1, 2, or 0, 1, and 3, or 2. Skip 2 there. Anyway, and now we can see we have 2 passing and 1 failing. But we don't know what they were testing. If we just look at the values here, if we just look at the names of what these are, we still don't know what they are. We just know that test 0 passed and test 1 passed, but test 2 failed. What does that tell us? We have to actually go and inspect them. So we can make this even better. So what we can do is actually expand on this unroll feature and actually inject some of these values into our string, into this function. And so comparing, what do we want? We want comparing value 1 equal to value 2 is the expected equality. And so this hash symbol is actually going to be sort of an escape and actually grab the value for this variable from that test. And so if I run this now, what we're going to see is we're actually going to see 3 tests, and it's actually going to have the values here. Or I did this wrong. Oops. What'd I do? Did I get ahead of myself? I might have gotten ahead of myself. Oh, I know what happened. I wasn't running all the tests in the project. I was only running that specific test, and I renamed it so it couldn't find it anymore. I'm going to run all the tests for this class, and that should find them. That wasn't my problem. That was just me screwing up. So now we get 3 tests, and comparing 2 equals to 2 is true. Comparing 2 equals to 3 is false, and comparing 1 equals to 4 is true. And so we can actually look at that test and be like, that's not right, and change this back to 1. And then if I rerun this, we'll see all 3 of them pass, hopefully. And there we go. So now we have 3 passing tests. Cool, right? So that's fun, that's cool, but there's more we can do. So let's create one more test. And what do we want to do? Let's mock out a yeah. Yeah, we'll do a consumable. So mocking a consumable gets called. So this is kind of a weird, this test is not going to make any sense. I'm not, yeah, it's just going to be a really quick way to actually demonstrate this. So what we want to do is say, given a fake consumable, when the consumable is called, then the consumable has been called once. And so what we want to do is we want to mock a class. We want to create a fake copy of that class that isn't the class. It's just got our own implementation of it. And then we want to say, when we call this, we expect it to be called once. So we want to make sure that that function got called and that it only got called once. So what we can do is, in this given statement, we can define a what? Consumable. It's actually called consumer. Well, that's confusing. And so we don't want to create just a consumable or a consumer. We want to create a mock of that. And so there's a few different fake types in Spock. Mocks are one of them, and spies are another one. And so the difference between those is a mock is completely empty. A mock has no implementation to it, whereas a spy is going to have the full implementation of it, but it's going to give you the features of a mock. And so we'll get into what those features are later. So now that we have this is effectively saying mock the consumer class. And so a Java consumer is a Lambda expression. It's a function that takes an argument and then returns nothing. So what we want to do is actually call that. So we want to accept and null, because why not? Another thing to note, Groovy, no semicolons. That's just a thing of the language. And so what we want to do is say 1 times the consumable.accept. And we don't care what the argument was, so I can actually put an underscore here. And that's sort of the wild card and saying we can accept anything. If you really want to make sure the function got a specific argument, you can actually give that here. And so this will say we got one invocation of the consumable.accept with a null argument. If you don't care, put the underscore. Or you can underscore multiple functions, or multiple arguments. So if there were 2, the consumer doesn't have 2. But if there were, you could wildcard say the second argument or something similar to that. So this way, we're going to assume that we create this mock. I may have done that wrong, yeah. But then we have this consumable.accept. We're going to accept a function. It doesn't actually do anything yet, but that's fine. And then we're going to check that at least one happened. So this is sort of a fun, fancy little Spock syntax that's saying we expect it's going to return a Boolean of true or false if 1 is equal to the number of times this function was invoked. And so it's kind of a weird fancy override of this function that is only applicable to mocks. Pretty sure it's only applicable to mocks. And so when you do this, you get hopefully a passing test. So if I run this, we're either going to get a compile error or a pass. Huzzah, we get a pass. So this passes. We know that it got called once. If I put a 0 here, it's going to give us an error, and usually it's pretty helpful. I don't know what I'm expecting. Too many invocations for, yeah. So the error we get is too many invocations for 0 times the consumable.accept null, matching invocations 1. So we got 1 invocation of it, and we were expecting 0. And it tells us that right there. So that's pretty handy. And you can even, if you invoke the wrong function, it can often give you a hint at that. And we can also say something else. So if we expect something else, this should also fail. And hopefully it will provide us with the null that passed. And it does. So we got too few arguments for this, but we did get one with the null. So that is how that whole thing works. And that is sort of part of what mocks can do. They kind of allow you to count things. Generally, it gets a little bit confusing, and this can be hard to maintain. But if you need it, it's there. The other really useful thing for mocks is they work really well for dependency replacement. So mocking by default can only be used to replace interfaces. That's why I had to use a consumer instead of like something else, some actual class. And so what we can do is replace them. So consumable.accept, we're going to say when we get a optional argument, so any argument, we are going to, I hope I get this the correct way, we are going to system out println hello mocked function. And so this is going to print out, when you invoke this accept now, it's actually going to print out a mocked function, or hello mocked, whoops, that's not right. It's going to print out hello mocked function. And so this is going to happen with any argument. And so this doesn't actually change our test. We don't get any different results. But what it lets us do is, say you have some dependency on some database or something like that. Null pointer. Did I go the wrong way? I might have gone the wrong way. I always get these mixed up. And there's one with 3 carets in both directions too. Yeah. Cool. So it did work. We get hello mocked function here in our output. So this is probably the most useful feature of a mock, and spies support this too. So what this allows you to do is, say you have a dependency on a database or some API somewhere, some external thing, and you want to really condense that down into the actual unit for your unit test. If you need to do that, sometimes you need to replace some of those external dependencies with mocked classes that don't do anything or that return specific expected data. And so what you can do is use this mock to actually implement that. And so in this case, we are creating an empty class, creating a consumer that pretends to be a consumer. And then when you invoke this accept, we're actually going to send out just a print line. This is less useful because it's just printing out something to the console. But if you want to actually return a result, like, I'm totally forgetting what the other consumer, there's a function, that's not right. Maybe it is. We'll pretend like this is correct. Say you want to return hello function. I don't know if this is correct, but if you want to do that, yeah. So when we apply this, then we're going to get back some expected result. And so this kind of gives you a way to do that, which is really handy, especially when you're working with like some really gross object-oriented code that has a lot of dependencies or has been broken up a lot, or you have some like central code that you're trying to kind of trying to make easier to test, something that is kind of sitting in between and connecting a few things to one another. This makes that really easy to do, and in a way that's pretty obvious. Like, this isn't a lot of code and it's fairly easy to read. So yeah, I think that's handy. So last thing before we wrap this up, mocks and spies. The difference between a mock and a spy is that a mock is empty. So this mock by default has no implementations. A spy, on the other hand, is going to have all of them, which means if you create a spy of a class, say that REST service that you wanted, that REST service is going to have all of its core functionality still. So if you just create a spy of something, by default, the only thing you gain is the ability to do this. You can check if a call was invoked or not, and that's it. But you can also override those functions. You can replace the functionality of part of a class using a spy. You can't do that with a mock. If you use a mock, it's totally gone. Highly recommend the mock over the spy, because if you're using a spy, it probably means that you haven't cut those clean barriers in your code, and so you have sort of overlapping functionality, or your classes are too broad and generic. So if you're running into using spies a lot, you might want to pull those out and do something else. But if you're using mocks or whatever, or just using the spies occasionally, they're really handy. So yeah, that's, I don't know, the basics of Spock. I like it. I was introduced to it like a year ago, and I thought it's a really clever way to do it, because you can still, if you just look for these labels, you can read this really quick and kind of understand what's going on. But then you can actually dive into the code, which is right next to it, and the code is fairly readable as well. And because it's in Groovy, a lot of the stuff is fairly easy to do, and the syntax is obvious. So like this table, you kind of understand that that's a table of values. Once you kind of understand Spock a little bit, you understand that that's a table of values that is going to be used in this test. And so once you kind of get that, it kind of all comes together. At least I think it does. So yeah, that's Spock. Yeah, if you guys have any suggestions for other things we should look at, or you want to see more of this, let me know in the comments. I would love to see what you guys have to say. But other than that, that's it for this video. So until next time, see you, Internet.